Hey everyone, and welcome to this explainer. Okay, so as an evolutionary biologist, I've got to tell you, there is absolutely nothing that geeks me out more than a closed ecosystem. It's like nature's own extreme science experiment. Today, we're unpacking the absolutely wild story of the largest, strangest lake in Earth's history, the Paratheces. If you're into how extreme environments just force life to adapt in completely unexpected ways, well, you're in exactly the right place. We're going to track the rise, the super weird biological oddities, and the total collapse of a prehistoric body of water that's going to completely rewrite what you think of when you hear the word lake. To even wrap our heads around the Paratheces, we first have to talk about its sheer mind-boggling scale. When this thing reached its megalake phase, it covered over 1 million square miles. We're talking about it swallowing up major chunks of modern-day Europe and Central Asia, stretching all the way across what is now Austria, Ukraine, Russia, and Kazakhstan. And 80? Yeah, that's the magic number here. To put that into perspective, if you wanted to fill up the Paratheces megalake, you couldn't just pour in the North American Great Lakes. No way. You'd literally need to take the entire volume of all the Great Lakes combined and pour them in 80 times over. As far as the geological record shows, it is the biggest lake in our planet's history, period. And it wasn't just massive, right? It was absolutely stunning to look at. Forget those murky, dark waters you usually associate with prehistoric swamps. Thanks to these massive blooms of phytoplankton and some really unique water chemistry, the whole lake turned this incredibly vivid color. Scientists actually call it Paratheces blue. Imagine standing on its ancient shores. You'd be looking out at this bright, rich turquoise expanse, just stretching forever into the horizon. Beautiful, right? But beneath that gorgeous turquoise surface, evolution was throwing a full-on tantrum. Okay, let's dive into how a lake this massive even happens. It's basically a journey of millions of years. Around 34 million years ago, shifting tectonic plates and the ongoing creation of the Alps literally pinched off the northern part of an ancient ocean called the Neothethes. For almost 20 million years, this trapped water was, well, a toxic, giant wet wasteland. An anoxic sea, totally depleted of oxygen, just a suffocating death trap. But then, if we fast forward to about 12 million years ago, bam! More tectonic collisions completely closed the region off. It lost all connection to the ocean, started filling with fresh water, and transformed into this fully enclosed, brackish megalake. The water stabilized at roughly one-third the saltiness of the ocean. And that specific tweak in the recipe, that set the stage for a total biological explosion. Now, putting my biologist hat on for a second, this is where the story gets truly spectacular. The Paratheces essentially acted like a giant water island. Because it was completely cut off from the global oceans, the marine animals trapped inside got hit with something we call insular isolation. Normally you see this on tiny land islands, right? Like large animals, think elephants, shrinking over generations because there just isn't enough food or space. But here, the island was a massive body of water, and the animals being forced onto this extreme evolutionary diet were marine mammals. Now, what's really interesting about this is just how dramatic that shrinking process was. I mean, when we say whale, you instantly picture a giant, don't you? But in the Paratheces, the whales shrank. Right in the middle of this wild evolutionary experiment is the Cephalotherium. It's a dwarf baleen whale, and hilariously, its name literally translates to whale beast. But honestly, this beast was tiny. The smallest adults were just over 6.5 feet long. Think about that. A fully grown prehistoric whale that was actually shorter than your average NBA basketball player. They had these weirdly oversized heads and rib cages, but these little shortened tails. And the Cephalotherium definitely wasn't a one-off. Look at that Titanocetus. Okay, actually, scratch the Titan part. Despite the name, it was anything but Titanic. It was another primitive baleen whale that shrank all the way down to about 20 feet. That's roughly the size of today's pygmy right whale, and honestly, it weighed less than an Asian elephant. You're probably wondering, wait, how does a filter-feeding baleen whale even survive in a lake? Well, remember those massive phytoplankton blooms we talked about? The ones making the water turquoise? Those blooms supported an absolute buffet of tiny organisms, meaning these dwarf whales could just cruise around filter feeding right there in the brackish water. And it wasn't just the whales drinking the shirking juice here. The entire marine mammal community got completely downsized. You had the heterodelphis, which were these little 6.5-foot prehistoric dolphins just darting through those turquoise waters. We also see this crazy abundance of seals. See, the brutal ocean predators, like those massive megalodon sharks that terrorize the older, saltier versions of the sea, they had completely died out when the water chemistry changed. So these seals were basically living in a predator-free paradise. They didn't need to be huge to defend themselves, so they stayed about the size of modern gray seals, just feasting on an unbelievable carpet of tiny, uniquely adapted snails and sea shrimps. So here's the absolutely crucial takeaway. While the marine mammals, the whales, the dolphins, the seals, were forced to become these weird miniatures of their ocean-going cousins, the rest of the ecosystem, yeah, it didn't play by the exact same rules. When we compare those dwarfed mammals with the fish and the land animals hanging out on the lake's shores, it's a complete 180. While the mammals shrank, some of the other locals blew up to gigantic, truly terrifying proportions. Just look at the apex predator of this mega lake. It wasn't a shark, it wasn't a killer whale, it was a fish. Specifically, a mega sturgeon. These brackish waters were patrolled by sturgeons that grew up to a staggering 23 feet long. Let that sink in. That is literally longer than the tallest recorded giraffe and right on par with a massive modern great white shark. Weighing over a ton, these absolute units completely dominated the food chain. If they acted anything like modern sturgeons, they were basically giant underwater vacuums, sucking up pretty much anything they could fit in their mouths, except maybe the whales and seals, and they'd probably even turn to cannibalism if they got hungry enough. And this bizarre size dynamic, it went right up onto the beaches. The Paratethys had tens of thousands of miles of coastline, all packed with life. One of the craziest residents was the Dinotherium. This was a massive, primitive relative of the elephant that stood over 13 feet tall at the shoulder and weighed a whopping 12 tons. That is way heavier than a modern African bush elephant. They had these very distinct downward-turning tusks for stripping branches. But here's the wild part. They were fantastic swimmers. So picture this. It is entirely possible that a 12-ton Dinotherium taking a dip could have literally crossed paths with a tiny 6.5-foot Cetatherium whale, the largest land mammals bumping into the smallest whales right there in the turquoise waters of prehistoric Europe. It was a thriving, completely bizarre, perfectly balanced evolutionary bubble, but it was still just a bubble. Which brings us to the big looming question. What could possibly kill an ocean-sized lake? Well, when you're a self-contained body of water, you are completely at the mercy of the climate. You just don't have that vast, stabilizing connection to the global ocean network to save you. And unfortunately for the Paratethys and all its weird and wonderful wildlife, the late Miocene epochs started throwing out chaotic, brutal climate fluctuations that this ecosystem literally could not survive. The end arrived in this devastating environmental collapse we call the Great Chersonian Dying, somewhere between 9 and 7.7 million years ago. It happened in a fatal sequence. Step 1. These severe, totally unrelenting droughts just baked the Eurasian continent. Step 2, the water levels plummeted by an astonishing 215 meters. That's over 800 feet. The lake literally lost 70% of its surface area and 30% of its total water volume. And then step 3, as all that fresh water evaporated, the salt concentrated and toxic salinity levels returned. This megadrought just wipes the slate clean. Those incredibly unique dwarfed whales, the small seals, the little dolphins, they all went extinct. They just couldn't survive in the shrinking, hyper-salty puddles of their former home. And this brilliantly illustrates just how dynamic and ever-changing our planet's geology really is. The Paratethys didn't just vanish into thin air. It basically shattered. It splintered into a few smaller successors. You had Lake Panone, which is completely extinct today. You had the Black Sea, which eventually reconnected to the Mediterranean, so it's not technically a lake anymore. And then the Caspian Sea. Think about this. When you look at a map today and see the Caspian Sea, which we officially recognize as the largest lake on Earth, you are literally just looking at a leftover puddle of the mighty Paratethys. But you know, as a biologist, I'm always reminded that the story of life is never really just about endings. It's about beginnings. The evaporation of this immense lake uncovered vast new land bridges and totally scrambled the climate of the surrounding continents. The death of the Paratethys forced this epic migration. Animals had to pack up and search for greener pastures. We actually hypothesize that the ancestors of modern-day elephants and giraffes, pushed out by this changing Eurasian landscape, migrated all the way down to the sweeping plains of Africa. It's an absolutely mind-blowing thought to leave you with. The tragic destruction of the greatest lake in Earth's history was the very catalyst that helped build the iconic African savanna ecosystems we know today. So what other lost worlds do you think are right beneath our feet, just waiting to be discovered? Thank you so much for exploring the Paratethys with me. Keep asking questions, and I'll catch you in the next explainer.